So now that you've had a chance to practice some of these names involving polyatomic ions, let's go over them. Our first step should always be to identify correctly the ions that we're working with. And once you do that, then we can go ahead and start figuring out the chemical formulas. So ammonium chloride. So ammonium is our cation. We know in any of our names that the cation is always going to be listed first. So ammonium, recall, is our one example of a polyatomic cation, NH4+. Chloride is just the chlorine atom with the as an anion, so Cl-. Since the charges here are equal, +1, -1, then we need just one of each, and so ammonium chloride, NH4Cl. Our next one is cesium phosphate. Cesium we find in group 1, which means we know it has a charge of +1. Phosphate, PO4, 3-. So in order for this compound to be overall neutral, we'd need 3 cesiums and 1 phosphate. Again, remember, just as we did previously, the number we get for each ion is in many cases going to be the subscript that we need to use for the opposite ion. Right. Calcium sulfate. Calcium 2+, sulfate SO4 2-. The charges are equal, we just need one of each. Lithium bicarbonate, lithium +1, bicarbonate, HCO3-. Again, equal charges, we need one of each, LiHCO3. And finally in this group we have strontium, strontium 2+, nitrate is -1. So we need 1 strontium and 2 nitrates. Again, we need to make sure that the nitrate, because we want 2 of the entire nitrate group, goes in parentheses. What would happen if you forgot the parentheses? Well, then it would end up looking like this. So if we forgot the parentheses, then it looks like we have 32 oxygens, and certainly we don't want that. Alright, our last bit here gets into what do we do if we have what we call molecular compounds. Or 2 nonmetals. What do we do in that situation? For example, if we have the compound NO, 1 nitrogen and 2 oxygens, or S2O3. So in these cases, it's a little bit different. Not a lot different, but a little bit different than what we did before. So we start by naming the first element, which is nitrogen. And then we, as before, we went IDE with the second element. But the problem is, that's not enough information. We can have elements that have 1 carbon and 2 oxygens, 1 carbon and 1 oxygen, and they're completely different molecules. So we're going to need to be a little bit more specific in the name. And we do that by adding a numerical prefix wherever necessary. And here's our list of numerical prefixes. So if we have 1, it becomes mono. 2 is di. 3 is tri. 4 is the one that students most often get wrong, and that's tetra. 5 is penta. 6 is hexa. Hepta. Octa. Nona. And deca. Now, when do we need a prefix for these? Well, any element that we have more than one of always needs a prefix. So in this second example, we have 2 sulfurs, so we need to call it disulfur. Then there's 3 oxygens, so it's trioxide. In this first one, though, we have only one of each element. Now, if our first element only has one, then no numerical prefix is needed. But we always need a numerical prefix for the second element. So even though there's only one, so there's one nitrogen, we don't say mononitrogen because it's the first element. If there was more than one nitrogen, then we would need a prefix. The second element, the oxygen, always gets a prefix. Prefix for 1 is mono, so this is nitrogen monoxide. So we can do 1 or 2 more of these. B2F6. So there's 2 borons, that's the first element, so we call it diboron. And then 6 fluorines, so hexafluoride. What about CO2? That would be carbon dioxide. All right, so this largely brings us to the end of Chapter 4. We will probably start a little bit of Chapter 5 this week, just sort of get into the very, very basics of Chapter 5. But as most of you know, and I'll post some other announcements about this online, the university announced today that we will be fully online for courses like this for the remainder of the spring term. And that is for both our lecture as well as our lab. In the coming days, I will be sending out some more information about what this is going to mean for us. But very, very likely, this is going to mean some significant differences in the way that we do exams in this course. While in general, I don't like to use multiple choice exams, the types of exams that I often like to use may not be feasible in this kind of setting. So this is just sort of a heads up that there are likely to be some changes coming in that regard. And as always, please let me know if you have any questions. Lastly, there will be a quiz posted in the next day or so. You'll have a couple of days to complete that. I'll be looking at some different ways to format that. I haven't quite decided on how that's going to look or work. But that quiz will, at this point, be covering primarily Chapter 1, so looking primarily at significant figures as well as unit conversions. The other change I'm planning on making to the way I post these lectures was originally I was planning on posting these lectures sort of as I would for each class period, and basically posting enough lectures for each class period. But now that we know we're going to be out and in this format for the entire term, I'm going to be posting these lectures by chapter. So that'll be the organization of them, and we'll be able to work through them in that way. When we get to each exam point in the course, at that point, I'll let you know what chapters are covered by the exams, and sort of that's the way we'll go from there. Again, I will also plan on sending out a fuller update about all of this by email by the end of the week. And again, if you have any questions, just please let me know.